Okay, good evening and welcome to, I think, the third stream. So, realising I should probably update title quickly on the stream. Okay, so where are we up to? I'll be honest, I'm feeling pretty tired. Sorry, today may be even more incoherent than the last streams, but this is good. This is part of why I wanted to stream this. I think it applies a bit of like good pressure to actually come back and do these things, so I don't just waste all my evenings sitting on the sofa. I think where we got up to was we'd started writing our first sort of chunk of meaningful Vulkan code. So if we dive in, we're now a renderer, and inside renderer we're picking a physical device, picking a device queue index, making a logical device, and picking a queue. Cool. I guess we had to start somewhere. I quite enjoyed the way I was working last time around. It's kind of new to me to work from the Vulkan docs directly, but I don't think it's the fastest way to make progress, but I do think it was enjoyable. So I'm going to go with that for now. And like I say, if we hit a roadblock at some point, we can always go back and refer to the working examples I've got. But I don't know, this feels like it's flexing my brain. It feels like I'm learning things this way. So let's see how we go. Trying to remind myself what next steps were. So I think if I remember right, I added this bookmark because somewhere around here, it ended up in the wrong place. Page 230. It's not actually jumping us to 230, interestingly. Okay, it doesn't seem to be going to where I had hoped it would go. I think that, if I remember right, there was an interesting list of things we could do now that we've got a queue, or now that we've got a physical device. I don't think that's the way we're going to go, though. So I think, like, these are coming later. Things like making command buffers, submitting commands, actually doing draws. Obviously, we're going to have to work out before we can display something. But the other side of that equation is we need to work out how to set up the thing we display to, if that makes sense. Which I remember being knotty, and I remember not really understanding very well. So I'm hoping we go through it slowly and painfully through the docs, and maybe we come out the other end understanding it better. I guess it's a bit of a teaser. I think, if I remember it right, what is involved is we're going to have to create a Vulkan window surface, which I guess is like the Vulkan interface to talk to the window that we've initialized in GLFW. I'm pretty sure GLFW has some nice stuff to help us with that and handles the platform-specific side of that for us, but we kind of need to link those two together. Once we've got a surface, our renderer will probably need to hold on to that, and is there an interesting point to think about there? So, to just output video for a game, and I think we'll do this dumbly first, just to make a thing work, we're going to need to initialize a swap chain, where my understanding is a swap chain is basically a series of images where one will be displayed and we can be writing to the others, and they can be kind of queued to be displayed. So your screen's refreshing at some frequency, and it will pull an image from the swap chain at the correct moment. If that sounds a bit wishy-washy, it's because I don't really understand it. What I do understand is underneath that, we have a bunch of images in memory. We're going to have to create Vulkan image views, which are kind of the Vulkan interface to give us access to that memory. And then we're going to have to work out, if the window changes size, then the size of those images all changes, so we need to update our image handles, we need to update our image views. So there's a bit of complexity in there to handle, and there's a bit of interplay between Vulkan and GLFW, so that's all a headache. And we're also going to need to create a frame buffer. I'll be honest, I don't remember very well what the difference between a frame buffer and the swap chain images is. So we're going to start there. I think that's our next step, is try and plumb all of that together. Before we do that, though, I was going to try and quickly set up the validation layers. I'm kind of hoping this might search effectively enough to just do validation layer and hope it pops up. I don't know if there's a nice way to see all of the searches results. So my plan with this, validation layers are, or at least I found them to be really, really useful for catching the kind of silly mistakes that you make when you've not got super familiar with something. So in particular, they will catch issues like when we get into synchronization primitives. If you've set up a semaphore that nothing ever depends on, so it's just kind of hanging out for no reason, the validation layers will kick in and be like, hey, what is the point of this? Do you need this? Which I found caught a lot of silly bugs. At this point, my plan now, we're going to try and enable the validation layer. I'm just going to enable it all the time. I think there is a runtime cost to enabling validation layers, but I can't remember for sure. We're going to enable it. We're not going to differentiate between different types of builds. I want them to run all the time while we're early on in this. And then we're going to make a teardown function. I don't think it's strictly necessary because our renderer and our everything are going to live for as long as our process, and then it will vanish and the operating system will tidy it up anyway. But I think it's useful for us if we do in the future want to do some sort of like screenshot thing, or we want to have it so we can have options that require the entire pipeline to be reset up, that we can just tear it down, throw it back up, and not leave memory hanging. So that's the goal. I don't know how we're going to find what the validation layers are called though, so maybe if I just ping through this, we'll hit something useful. And if not, I might just Google and try and find what the name of the validation layers is. Yeah, this is struggling, isn't it? Okay, let's not do it that way then. Let's go and have a look. So we want Vulkan validation layers. My god, that's very zoomed in. We've got the Kronos group repository that does it. We've got the Vulkan tutorial bit that explains it, which might be the best place to go. Vulkan documentation. Interesting. Do a full overview of how Vulkan deals with valid usage of the API. Yes, this is what we were saying. It'll catch all the places that you're doing things you shouldn't be doing, which is really useful. Is there anything in here to explain getting validation layers? Since Vulkan doesn't do any error checking, it's very important developing to enable them right away to help catch invalid behavior. They should never ship with them, as they noticeably reduce performance and are designed for development. Yeah, that's what we were saying. So I think eventually we're going to add a flag to be like, we're going to have probably a make file or something to separate our debug builds and our proper builds, but let's worry about that in a bit. Okay, so we've installed the Vulkan SDK, so I'm assuming I've got them. Debug report callback, debug utils callback. Neither of those tell me how to actually use it. A VU is defined in the spec, GL get error, valid usage. What's the name of the extension that I need to enable though? I'm pretty sure that's how this works, is it? Oh, it's not an extension. Is it an extension or a layer? Breaking down a message, we can see it in here. Will this tell me validation layers, docs, images, readme, best practices, the Kronos validation layer? That might be it. We have the readme, VK equivalent layer, Kronos, validation overview. Come on, I just want to know what the name is. There we go. Is that going to be it? So we have a layer setting, which is this string, and we'll have to work out where we actually enable that. I guess, is it on the instance? Environment variables layer setting. We suggest using the Vulkan configurator. So yeah, this is one of those things that I think, if I remember right, I think maybe in the first stream I mentioned that there is a more modern Vulkan tutorial than the one that I learned off. And I think that it makes broader use of a lot of these like Vulkan ecosystem tools that I'm sure are really useful as things get more complicated, but I kind of want to do it all from scratch at least a couple times and get my head around it. Which may be an error, but we'll see how we go. Okay, so we want this thing. Can we see... Where would we be looking? Is it on the device? Device Q index. So when we make a logical device, does this have enabled layers on it? You have queue priority, so it's not because you're making the queue. Vague memories of seeing something about this. Yeah, so you have an enabled layer count and enabled layer names. So maybe we just try and see if it works. So what are we going to do? We'll come up here and make an enabled layers. We'll make it... What's the thing to do? I guess a list of C strings? Because they're all going to be C strings, I guess. And then let's just copy paste this. I think this is how you go about doing it. Let's see if this just works. So U there will then be enabled layer count is the len of enabled layers, and this will be a raw pointer to enabled layers. Didn't work. Why didn't you work? Are you going to be the wrong type? Type of int U32. Let's cast it. Undeclared name raw pointer. Why is that undeclared? It's called raw data. There we go. So it passes the LSP's checks. Let's see, Odin, run main. Okay. That looks like it worked. How can we now check if it did work? So I think all of this is inside of a function we're calling init renderer. Do we make a teardown function? Call it dinit, or do we call it teardown? I'm going to go with dinit, just because it's kind of obviously the opposite. So dinit renderer, I'm guessing this returns a renderer. So can I go dinit renderer, renderer? Let's make it a pointer to renderer. Is that what we want to do? Why is that not allowed? Is that how you do it? Didn't think that's how types worked in Odin. I thought I had to put like this. Expected. Oh my god, I'm just doing everything wrong, aren't I? You do this is a proc that. Do any of these things error? I don't think any of these things error, so let's just come in here. And I think, yeah, they're quite good about making everything very formulaic. So the same way that creating things in the Vulkan spec is always done with, like, you make a thing create info, then you do create thing. The opposite, when you want to free all of the memory and the resources, you call it destroy. So I'm hoping if we come in here and we do destroy renderer device, p allocator is null, and do we have to provide the instance as well? No. Okay, so you provide device, and we've not got our own allocator, so that is null. We run. I don't think that worked, because I expected to see a bunch of stuff complaining that we weren't destroying. Do we have to destroy queues separately? Queues might be managed as part of the device. That might be why it was fine. In fact, we can probably look that up. If we go in here, queue, Devices in queues, queue creation. Is there anything in here about destroying queues? Get device queue. Gives you a queue object. Yeah, logical device that owns the queue. The fact it owns it implies maybe it gets destroyed. It would be nice to find something really explicitly saying that though. Queue destruction. Queues are created along with a logical device using during the create device. All queues associated with the logical device are destroyed when the device is destroyed. Cool, so it didn't complain because actually that is valid usage. Oh, that's a point. So if we do this, should we also be nilling out all of those handles? That feels like a lot of extra effort. I'm going to instead say we'll just try and avoid a bug where we're using a de-initted renderer, because things will just fail horribly. Hopefully we've got that working. I'm sure there's a way to check what layers you have running, but I don't know what they are off the top of my head. So we're just going to assume that's good. It didn't error. It didn't block. That's a question, actually. If I come in here and I put something silly in, VK layer Chronos, I don't know. Does that complain in some way? No, that's interesting. It just fails. Interesting. Oh my goodness! If I could type, I would be dangerous, wouldn't I? Yeah, because I thought that maybe it would fail at this point. Should we have a look in create device? It should probably actually, if I come in here, device. We have devices. Somewhere in here we must call create device, surely. Extension names is not what I'm doing, it's layers. VK create device as a create info. Verifies extensions and features in this and this. If any requested extension is not supported, it must return that. Does it do the same for layers though? Return codes, out of host memory, device memory, initialization, extension and feature. So again, not layers. Inside of all of this. Ah. Okay, that might be why. Because it's been deprecated. Does it say what we should use instead? Enabled layer count is deprecated and ignored. Device layer deprecation. Previous versions of the specification distinguish between instance and device layers. Ah, should we be doing it on the instance? Is that what that means? So that's wrong. Is it going to be that... When did we actually make our instance though? Do we actually make the instance back here? Outside of that, we have application info. That doesn't have anything in it particularly. You get extensions. Do you also have layers? You do. How interesting. So what is this going to tell us? Device-only layers are now deprecated, and this specification no longer distinguishes between instance and device layers. Layers are enabled during instance creation and are able to intercept all commands operating on that instance or any of its child objects. At the time of deprecation, there were no known device-only layers, no compelling reason to create one. Interesting they kept it in the spec rather than just being like breaking change. I guess maybe they're very anti-breaking change. In order to maintain compatibility with implementations released prior to device layer deprecation, applications should still enumerate and enable device layers. The behavior of enumerate device layer properties and valid usage of the PP enabled layer names member of device create info maximizes compatibility with applications written to work with the previous requirements. Okay. To enumerate device layers, you call enumerate device layer properties. This thing, this thing, this thing. The list of layers enumerated must be exactly the sequence of layers enabled for the instance. Enumerate device layer properties. Is that saying which ones are enabled, or is it saying which ones can be enabled? Must be the same as the properties when the layer was enumerated by VK enumerate instance layer properties. Okay, so it's saying if you use the old version and the new version, then it should behave the same way. The sequence of layers active for a device will be exactly the sequence of layers enabled when the parent instance was created. Yeah, so the thing we were touching didn't do anything because it shouldn't do anything. And we should instead be interacting with this. So let's move that. Let's put it, I guess, in here next to all of this stuff. And we'll go to where we create our instance. And it will be enabled layer count is equal to something, and pointer to pointer to enabled layer. No? What do you mean no? PP enabled layer names. Yeah, that's what I thought. Because there's a syntax error before it, it freaks out the OLS. It is a shame. I think the language server's not great. I kind of wonder. I know I've seen, I think, is it Ginger Bill, who the guy who wrote Odin is very anti-LSP and doesn't use one. And so it's like community driven. It's pretty bare bones. Yeah, to be fair, my NeoVim setup is also janky and bare bones. I've rewritten it somewhat recently because I think there may have been like a breaking change in a Mason update that just annoyed me, and I didn't want to have to go back and redo everything. And I had a bunch of LSPs that I had to configure manually myself anyway, because they weren't supported well in Mason. So I figured I would just kind of raw dog it and put it all together myself. I'm not sure it's working quite right. So maybe that's a future stream. Maybe we can go through and spruce up my NeoVim thing. I'm sure there's probably more NeoVim knowledge out there than I have in my head. I'm not great at it. Right. So let's do our cast of that for my god, what am I calling it? Is it called enabled layers? Yeah, there we go. And then this will be a raw data again for enabled layers. Hopefully that still runs. Redeclaration of enabled layers. Did I not write? There we go. And again, we're not expecting anything to fail. Now though, if I come up here and I say make this a nonsense value, then it fails. Nice. Oh, it doesn't fail with a nice message, does it? That's because I'm just panicking. Yep, that's totally on me. Okay, let's put you back. Check you run. Beautiful. Okay. Well, that took me longer than I thought it would. Let's just check. So the changes in main are the ones we want, and we do want that. So let's say there we go. Enable validation layers. So now every time we run, if we do something really stupid, it should spit a load of output out. To be fair, the output they spit out isn't like the most, I don't know, like human readable friendly output, but it does give you very specific pointers to things that will tell you what you're doing wrong. So I found it's useful. Cool. That's step one. What did we say we were going to do next? Next, we were going to have a look at how we go about doing window surface creation and swap chains. I think if we look in here, yeah, this Windows system thing I think is what surfaces will come under. And it's why I'm pretty sure, there we go, WSI surface. I'm pretty sure this has a nice wrapper in GLFW that we might want to use. But let's just have a quick read. So native platform surface or window objects are abstracted by surface objects, which are represented by VK surface KHR handles. KHR I think stands for Kronos. So it's not part of the core spec, but it is one of their, I guess, core extensions. Is that a silly phrase? Whatever it is though. So it's a handle. The VK KHR surface extension declares the VK surface KHR object and provides a function for destroying VK surface KHR objects. Separate platform-specific extensions each provide a function for creating a VK surface KHR object for the respective platform. From the application's perspective, this is an opaque handle, just like the handles of other Vulkan objects. And so I think in our code we have this. In fact, we've just seen it, haven't we? What's it called? GLFW required instance extensions. I think what this will do, yeah, we can't see it here easily, is it will be doing that platform-specific extension. It will be getting that list that we need. In my case, it checks and sees I'm on Linux. I'm using, like X11 for my window management, so it lines up the right extensions to interact with that. Is this note interesting? On certain platforms, the Vulkan loader and ICDs, installable client drivers, I think. It's basically graphics drivers. May have conventions that treat the handle as a pointer to a structure containing the platform-specific information about the surface. Okay, I think that might be more detail than we need. We are not doing anything on Android. In fact, does this expand? That'd be nice. It does not. Okay, never mind. Is it because I've got that? It does expand. Presenting directly to display devices, querying for support, surface queries. My God, there's a lot in here. Swapchain is also in here. Okay. Let's try and skim past all this Android stuff and see if there's anything we care about. Yeah, so this is getting into all of the platform-specific bits that I'm hoping we can avoid caring too much about. I am curious though. XCB, is that what it'll be using? Oh, that's interesting. So it could be using XCB. Is there also going to be one for, yeah, for Xlib? So I don't actually even know which of those it'll be using. Okay, but it is just calling it into something. So I think probably we find the GLFW function. It will call the appropriate one of these based on the same rules it's using to select which extensions we want. And we're good. We're Gucci. Don't know why I said that. That doesn't sound much like me. I think that's a Soding line, isn't it? Well, whatever it is. My God, there's a lot of these, isn't there? So we keep going. Oh, there's hundreds of pages of it, or dozens at least. Presenting directly to display device. In some environments, applications can also present Vulkan rendering directly to display devices without an intermediate windowing system. Okay, interesting. We aren't doing that though, so let's bail on that. Not all physical devices will include WSI support. Within a physical device, not all Q families will support presentation. WSI support and compatibility can be determined in a platform-neutral manner, which determines support for presentation to a particular surface object. Okay, so at this point we've got a surface, and we can then check that our physical device Q family index is supported, which it'll output to this piece supported. Okay. So I think our first step, we're going to need to make this surface, and then we can go and check that things are supported. And I guess probably, how do we want to go about that? Is that done with the instance? It's done with the physical device and the Q family index. So, since the surface represents a window, and we've already made a choice that what we want is our window to sit outside of our renderer, right? We want the renderer Oh my god. Does that even make sense? Or should we just put the surface inside of the renderer? I might make it sit outside just because it'll be easier to suck it in than it would be to just pull it out later if... Don't even know what I'm saying. Let's stick it outside. Let's stick it in here. So we'll have a VK, is it surface KHR, which it does know about, which is a good sign. So that's going to live in our global context. So down here, we initialize GLFW, we create our window, we initialize the Vulkan instance. Then before we init renderer, I think we're going to want in here to say create our VK surface. Should I do it in actual English? Create a Vulkan WSI surface. Let's go find the call for that again. Oh no, this is what we were saying. We think we need to do this through GLFW. GLFW create Vulkan surface. The Vulkan guide create window surface. About Vulkan using GLFW to abstract a waste surface from 5 years ago. GLFW from a year ago. You create a Vulkan surface. Is that the same thing? Yeah, it looks like the same thing. Let's go into this one then. This might actually be interesting to read through completely. So what's it say? This guide is intended to fill the gaps between the official Vulkan resource and the rest of the GLFW documentation, is not a replacement for either. To develop the Vulkan, you should download the LunaG Vulkan SDK, very true. Vulkan tutorial is presumably, yeah, it's just vulkantutorial.com. The Kronos Vulkan samples also use GLFW, although with a small framework. For details on a specific Vulkan support function, you should go to their reference. Okay, so linking against the Vulkan loader. By default, it looks for a Vulkan loader on demand at runtime. This means that GLFW does not need to be linked against the loader. However, it also means that if you are using the static library form of the Vulkan loader, GLFW will either fail to find it or worse, use the wrong one. GLFW Vulkan static CMake option. Okay. We have a thing that is currently working, and so we'll worry about that if and when we need to. To include the Vulkan headers, do this. If it says you want to include the Vulkan header from a custom location, do that. Again, it's working, so we're not going to worry. If you're linking directly, then you can skip this section. The canonical desktop loader library exports all Vulkan core and Kronos extension functions, allowing them to be called directly. If you are loading the Vulkan loader dynamically instead of linking directly against it, you can check for the availability of a loader and ICD with this. I'm going to hope that I don't need it. Querying Vulkan. This is the thing from the first stream that I didn't understand very well. So querying Vulkan function pointers to load any Vulkan core or extension function from the found loader. Call GLFW get instance proc address. Is this stuff all wrapped up inside that Odin library function, and then we passed it in this? Okay, so to load functions needed for instance creation, pass null as the instance. Cool. Once you have created an instance, you can load it. You can load from it all other Vulkan core functions. Yeah, that's what we were saying. So it passes in a string for the name of the function that we want, and it will go and get the function pointer for that function for this instance. This function in turn calls VK get instance proc address. There. If that fails, the function falls back to a platform-specific query of the Vulkan loader. That also fails, it returns null. Go and see the Vulkan docs. Okay, I'm still not sure I've got that all together in my head, but we plow on To do anything useful in Vulkan, you need to create an instance. If you want to use Vulkan to render a window, you must enable the instance extensions, which we have done. These extensions must be enabled when creating instances that are going to be passed to GLFW get physical device presentation support and GLFW create window surface, which we have done. So we're getting there. The set of extensions will vary depending on the platform, may also vary depending on graphics drivers and other factors. If it fails, it returns null. We're checking that. If it fails, it returns null, and GLFW will not be able to create Vulkan Windows surfaces. You can still use it for off-screen rendering and compute, which makes sense, right? All of the, well, I say all of, most of the trickiness between different platforms is in the windowing. So you actually could be null. If it passes back null, then this will have length 0. So let's just stick that in here to just check we're getting something. Instance extensions. If the length is 0, right? Because if it passes back null, then this is presumably a my god, I can't talk. This is a slice of C strings, and C strings are null terminated. So if it passes back null, we've got a 0 length array or a 0 length slice. If the length of that is 0, what do? Panic. Get required instance extensions failed. Can't present to a window surface on this system. Let's go just check that that's working. Cool, so that's not blowing up. Then, what do we have? If successful, the returned array will always include surface, so you don't have to require any additional extensions. You can pass this list directly into the create thing. Additional extensions may be required by future versions of GLFW. You should check whether any extensions you wish to enable are already in the thing. It's an error to specify an extension more than once. Interesting. macOS has some complications. Querying for the presentation support. Not every Q family of every Vulkan device can present images to surfaces. To check whether a specific Q family of a physical device supports image presentation without first having to create a window or surface, call this thing. And we pass it in the Q family index. Interesting. I think when we were grabbing our Q, actually, I got confused by this, because I've enabled it for graphics and transfer operations. So the queue we're grabbing is the first queue we find that has both of those available. I guess we just extend that to also check that get physical device presentation support is enabled. So we're grabbing the first queue that can do all of those things. So let's have a skim down. Pick a device queue index. We get the physical device queue family properties. And then found is false for Q family properties and index. Both supported. It's kind of a rubbish name now, right? So let's say graphics and transfer supported. We could have a break in there, couldn't we? Instead of going around with this. Found equals true. Okay, let's worry about that in a minute. So graphics and transfer supported is this. I also now need to do a present supported is equal to, we're going to just say true, and we're going to say in here that we require that present is supported. Cool, no silly mistakes made. And we call that with instance physical device and Q family index. So glfw dot, how do I keep forgetting? Get physical device presentation support. Get physical device Q, was it? Q presentation support. No, get physical device presentation support. Beautiful. Ah, that's why we've not imported GLFW. So let's go get GLFW, vendor, GLFW. Because that's the same, we can just do it like this, except that I cannot type. So you down here are blowing up because it's missing things. It wants an instance, it wants a physical device, and it wants a queue family. Our instance is renderer dot. No, it's not renderer dot because it doesn't live on there. It's in our global context VK instance. Our physical device does live on the renderer. So physical device. And we're going to want index. Index is probably the wrong type, so we cast it to a U32. Nice. Let's see if we still find something, and we do. So that's good news. Let's see. The extension provides the function which performs the same test on existing Vulkan surface. Ah, okay. You could create the surface first and then test, but that seems a strange choice. Ah, actually, is it a strange choice? It might not be a strange choice. We're about to actually create our surface first. Okay, let's try that then. So we'll copy this. This function which performs the same test on an existing Vulkan surface. So why does it matter which of these you do? Ah, because one's GLFW and one isn't. And we're doing each of these on the queues. So at this point we have a surface. So actually, can we do it where we're going to do VK dot get physical device surface support. Get physical device surface support KHR. You take a physical device, a queue family index, a surface, a pointer to supported, and a result. Is it nicer to do it this way because it keeps it within the Vulkan stuff though? We may want to not use the other one. Do you know what? This just seems simpler. So I'm going to do it this way around. Because, yeah, like I say, it just seems a little bit backwards to... Well, not even backwards, it just seems simpler. It just seems like it takes in less things. I don't see any reason for it to prefer one over the other. We're already using GLFW everywhere. It'd be quite a big refactor to get rid of. So let's not worry. Okay, creating the window. We are doing... Oh, no, I didn't want to click that. Creating a window surface. You can create a Vulkan surface as defined by the extension with GLFW create window surface. GLFW create window surface. If a OpenGL context was created on the window, the context has ownership of the presentation on the window, and a Vulkan surface cannot be created. It's your responsibility to destroy the surface. GLFW does not destroy it for you. Call destroy surface KHR from the same extension to destroy. Okay. So do you know what? Let's take that. I would like to come back to here. Where am I looking? Initialize Vulkan instance. We're creating this thing. So let's come in here. That's the thing we're going to call. It takes in an instance, a window handle, an allocator, and a pointer to the surface. Does it return anything? It returns a result. So let's go ahead and say res is equal to glfw create window surface global context vk instance global context window nil for our allocator and a pointer to our surface. So let's do GC VK surface. If res is not equal to success, then we'll panic. Create, I want to say VK KHR window surface failed. Window surface failed. Let's bin these lines off. Oh my god, what have I done? Let's try that again. There we go. So you run, we've got the surface, lovely. Since we've got the surface, I wonder if we could clear it. That might be nice. Although I don't know, that might be coming later. Let's not jump too far ahead of ourselves. Okay, cool. That feels like step one done. I expected to see a validation error. Because no, I shouldn't see a validation error because our surface is being created on the instance, not on the device, right? So we probably should. No, it's not even tied to the renderer. Okay, I'll tell you what. I'll put a defer glfw. What's it called? Destroy. It's not in glfw. VK destroy surface KHR. So let's go VK destroy surface KHR. Just so I remember that's a thing that we may want to do. Yeah, VK surface didn't work because surface is missing. It probably takes the instance. It takes an instance, it takes a surface, and it takes nil. So GC instance, GC that, and nil. It's because you're not called that, you're called GCVK instance. So you run happily. Nothing blows up. Just for sanity, we check. So we're adding the surface to our global context. We've added a sort of belt and braces check that our extensions are actually enabled so that we know that when we try to create this thing, it'll work. And then in renderer, what have we done? We've added a check that present is actually supported, which is good. And if we don't find a queue that can do everything, then we flame out. So what we call this? VK WSI surface creation. Beautiful. Right, so what do we do after that? After that, we get onto swap chains. I don't really remember what we do there. So let's just say swap chains coming next. And I am going to run to the loo, so I'll be back in 1 minute. Okay, and we are back in business. So let's think. How are we going to go about this swap chain stuff? I think we might end up having to look at the docs for a while. Which, I don't know. I think this is working quite well. I appreciate, I think it's going quite slowly. There's a lot of pruning through docs, but I don't know. I think I've been through the Vulkan tutorial a couple of times, and there's something about working through a tutorial that presents you with code that's going to work, that even with the best of intentions, I think you just can't help but start sort of autopilot copying your way through it. I think I mentioned in the first stream as well, I wouldn't be surprised if actually, you know, like any of the AI Copilot style completion tools actually do a really good job of completing for Vulkan API calls. But you know, at that point I feel like I'm just going to turn my brain off. I might as well copy paste in somebody else's renderer and play with it at that point. So I think it is slightly painful, but I think it's probably a good flavour of pain. So we're going to plough on, slow and steady. I'm just realising this is probably actually a little bit small on the stream. So that first hour might have been a bit painful. That said, actually, I'm slightly surprised. I guess both at the skill of actually talking through what you're doing as you're doing it. I think it's interesting to look back and see how incoherent those first couple of streams actually sound in parts. And also, I don't know, there's something about working with your text blown so big that makes it surprisingly difficult to get a good sense for like where you are in your file. But, you know, we'll learn. Hopefully I'll improve. If I don't, it'll be a bad experience all round. Sorry, I'm just going to have a sip of drink because I think my throat is catching up with me again. Okay, so let's plough on. I think, can bin these now. Yeah, let's get rid of all of that. And let's start working out what we're going to do with the swap chain. Actually, it doesn't mention the swap chain for quite a long time. There's hundreds. Are there hundreds of pages? 336. There's about 100 pages between surface and swap chain. I'm curious what we're talking about with surface queries. The capabilities of a swap chain targeting a surface are the intersection of the capabilities of the WSI platform, the native window or display, and the physical device. The resulting capabilities can be obtained with the queries listed in this section. Okay, so we are probably going to care about all of this. To query the basic capabilities of a surface needed in order to create a swap chain, call this thing, where physical device, surface capabilities as a structure that it will put it all in, and it has on it current min and max extent, min and max image count, max image array layers, supported transforms, current transform, composite alpha, and supported usage flags. Interesting. So this is the surface telling us what it can do. And we're going to need this information when we make our swap chain. The min image count is the minimum number of images the specified device supports for a swap chain, and will be at least 1. The max image count is the maximum number of images the specified device supports for a swap chain created with the surface, and will be either 0 or greater than or equal to min image count. A value of 0 means that there is no limit, that there may be limits related to the total amount of memory used by presentable images. Interesting. Current extent is the current width and height of the surface, or the special value, just max int, indicating the surface size will be determined by the extent of a swap chain targeting the surface. Then we have a min max image extent, where min contains the smallest valid swap chain extent for the surface on the specified device. Width and height of the extent will each be less than or equal to the corresponding width and height of current extent, unless that has the special value described above. And the max image extent contains the largest value that's allowed on the specified device. The width and height will be greater than or equal to the corresponding value on the min image extent, and they will each be greater than or equal to the thing unless it's a special value. Max image array layers, the maximum number of layers presentable images can have for a swap chain created for this device and surface, and will be at least 1. Supported transforms, indicating the presentation transform supported by the surface. At least 1 bit will be set. Current transform, indicating the surface's current transform. And supported composite alpha, representing the alpha compositing mode supported by the presentation engine for the surface on the specified device, and at least 1 bit will be set. Opaque composition can be achieved in any alpha compositing mode by either using an image format that has no alpha component or by ensuring that all pixels in the presentable images have an alpha of 1. And then supported flags. Okay, I remember present mode. It's one of these. We want to pick one of these that makes image tearing impossible, if it exists, and if it doesn't, then one of these is always enabled, I think. Okay. Well, I did say I remember this being complicated. It's surprisingly complicated, right? It's one of those that you'd have thought it's basically I want the swap chain that matches the window, but I guess not. There's a bunch of extensions that I think we don't care about. VK surface capabilities 2. There's a whole heap of stuff. Okay, maybe what we do is we'll jump down to Swapchain. Let's get our head around what a Swapchain is. And I think, like it says, we're going to have to go back to that surface queries point to get the fields that we need when we want to make our Swapchain. So, WSI Swapchain. A Swapchain object provides the ability to present rendering results to a surface. Swapchain objects are represented by VK Swapchain KHR handles. A swapchain is an abstraction for an array of presentable images that are associated with a surface. The presentable images are represented by Vulkan image objects created by the platform. One image, which can be an array image for multi-view or stereoscopic 3D surfaces, is displayed at a time, but multiple images can be queued for presentation. An application renders to the image and then queues the image for presentation to the surface. A native window cannot be associated with more than one non-retired swapchain at a time. Further, swapchains cannot be created for native windows that have a non-Vulkan graphics API surface associated with them. So this is what we saw GLFW warning us about, that if OpenGL is set up to use it, then we can't use the Vulkan stuff. The presentable images of a swapchain are owned by the presentation engine. An application can acquire use of a presentable image from the presentation engine. Oh, what's a presentation engine? Should I not skip this note? The presentation engine is an abstraction for the platform's compositor or display engine. The presentation engine may be synchronous or asynchronous with respect to the application and/or logical device. Some implementations may use a device's graphics queue or dedicated presentation hardware to perform presentation. I'm not sure what that's telling me. So presentable images of a swapchain are owned by the presentation engine. An application can acquire use of a presentable image from the presentation engine. Use of a presentable image must occur only after the image is returned by VK acquire next image and before it is released by QPresent. Okay. So I think what this is saying is our application doesn't own the memory for those images. We're going to request them from the presentation engine, whoever that may be. I guess probably part of the X11 side of things. But we're going to request an image from it, and it's ours to use after we acquire that image until we queue the next image. Sorry, I'm yawning. Okay. So an application can acquire use of a presentable image with VK acquire next image. After acquiring a presentable image and before modifying it, the application must use a synchronization primitive to ensure the presentation engine is finished reading from the image. Cool. Okay. So that's a bunch of stuff that we're going to have to worry about later. Where maybe it's not come up yet. Vulkan, I guess for the sake of generality, imposes no sort of restrictions on what you do when. It's entirely on you to set up. I remember right, I think it's semaphores for making sure things happen in order on the GPU, and then fences for making sure that the CPU and GPU are kind of in sync with each other. So that's a whole heap of fun for us to worry about, but I think we worry about that when we get to it. What else is this? The presentation engine controls the order in which presentable images are acquired for use by the application. This allows the platform to handle situations which require out-of-order return of images after presentation. At the same time, it allows the application to generate command buffers referencing all of the images in the Swapchain at initialization time rather than its main loop. Don't know what that's telling me. How this all works is described below. If a Swapchain is created with present mode set to either that thing or that thing, a single presentable image can be acquired. We're not doing that though, because then you get screen sharing, I think. So if we ignore that, I don't think we're going to do any of that. A shared presentable image at any time after the first, so I think we're not going to do any of this, so that's probably not worth reading. Possible return values for the get Swapchain status, success, suboptimal. So this we are going to care about. So suboptimal I think we're going to call to handle screen resizing. But again, let's worry about that later. So we come all the way down here. To create a Swapchain, we call this, which looks nice and simple. Can I put this next to the code? I think I did this in the last one. It looked fine, if I remember right. So let's do something like this. Just going to wait to see what it looks like on the stream. I think that's readable enough. Let's go with that. So I did commit, didn't I? Yeah. We are going to, I guess, add a Swapchain. Could be a VK, Swapchain KHR, and down here we're going to pick a physical device, pick a Q index, make a logical device, get our Q handle, and create Swapchain. Now, there might be an argument for pulling this out into a function, because I'm pretty sure this is a thing we end up having to call again to handle screen resize. I keep saying this. When the screen resizes all the images involved in the Swapchain resize, so I think you have to basically bail out and go and grab a new one. And there's a load of cleverness about like retiring one but not wasting the images that were generated for that one that I think we just don't worry about. I think we bail and grab a new one and just start again. But let's just keep it in line for now, just for, like I think I've said this before, I quite like when I'm playing with things I don't know very well to have this kind of top to bottom readability. So I don't know, I find it makes it easy to keep it straight in your head what's actually happening. So we're going to want to call create Swapchain KHR with our renderer device, our create info that we've not made yet. We've got no allocator, and we're going to set it to our renderer Swapchain, like so. That will give us a result, and whoopsie daisy, if result is not equal to success, then we will panic with failed to create our Swapchain. If we come back up to here, we need to make a create info. So create info will be equal to a VK create Swapchain info. I'm pretty sure that's what it'll be called. Maybe with a KHR. Yeah, you don't exist, do you? Create. It's gonna be called Swapchain create info, isn't it? Swap. Has that worked? There we go. Yeah, I'm pretty sure I've got something set up wrong because none of my completed stuff seems to be working quite right, but we made a lot. We're getting through. I think maybe this is good. Maybe this is, we'll call it good, like brain training. I'm flexing my ability to recall information. Let's use that as our excuse. We are going to need to skim past a lot of this. My God, what is this? That's not what I expect to see. As mentioned above, if it succeeds, it will return a handle to a Swapchain containing at least min image count presentable images. Okay, but where's the rest of my... Where's the create info? Struct. Did I just miss it? There we go. VK create. My God, I can't read. VK Swapchain create info KHR has so many fields. Okay. Well, let's do the easy one. S-type is the same silly thing it always is. I'm forgetting the syntax is equals, and then we can do swapchain create info KHR. There we go. So you're needed. Pnext, I'm hoping we don't need. So I guess if this is the first one of these you've seen on the stream, we use Pnext if we want to use extensions. Basically, it's the mechanism that the Vulkan API uses to make things extendable. If it's non-null, it points to another struct, and that struct will have a type on it to say what it is. And then if you've enabled the extension that lets the loader handle that, then it'll do something that the core spec didn't account for, which is nice. We don't need it. Swapchain create flags. I guess depends on what those flags do. Can I just do that for now? So flags is going to be an empty value. If I come in here and say it's going to be swapchain create flags KHR, if we jump in here, protected, mutable, deferred memory allocation extension. Okay, let's hope we aren't setting any of those because I don't know what they mean. We need our surface, so let's get our surface. Lovely. Not happy. Doesn't have a surface because it's called VK surface. Min image count, image format, image color space, image extent. I think is all stuff that we need to do that querying for. Usage sharing mode. Q family index count, Q family indices. Pre-transform, composite alpha, present mode. Present mode we also need to do that querying for. Clipped an old swap chain. So I'm pretty sure old swap chain is going to be nil. Because I think that's to do with this retiring swap chains business. Flags, we're hoping we don't need any. Surface, we've got min image count is the minimum number of presentable images the application needs. The implementation will either create the swap chain with at least that many images or will fail. So, can I call... I know our last attempt at a bookmark didn't work very well. Can I do an annotation instead? Inline note. Do they work if I do this? Swap chain create info. Can I deselect that? And then if I click it, is there a reason it's so small? Ooh, interesting. Okay. So if I do that, can I jump to those? Is there a way to get like annotations? There is. Although annoyingly, it doesn't actually say on here what it is. That's a shame. Open pop-up note. Okay. Can I rename it here? No, it doesn't look it. Appearance, general. So no, actually we are probably better off using bookmarks and just hoping they end up in the right place. So if we add a bookmark there, and your name is Swapchain create info, because we don't want to get back here. It was back up here in surface queries was a bunch of this stuff, wasn't it? So it did warn us we're going to need to make a bunch of surface queries, so let's go and do that. Okay, so let's have surface query res is equal to vk get physical device surface capabilities KHR. We don't need version 2 because we're not going to extend it. And inside of here we have our physical device that lives on our renderer. So we can do this, our surface that lives on the global context, and a pointer to our surface capabilities. You don't exist yet, so we need to come up here and we need to do surface capabilities is a VK surface capabilities kjar, like this. Okay. Shall we print that? Is that going to be enormous? That might be enormous, but I'd be interested to see it. So if we do format, print line, surface capabilities, can't type. So we run you. Whoopsie daisy. Let's head back here. Let's put things back how they were. Make it big. Hit the wrong button. Okay, so it aborted. That's interesting. Okay, so what do we get? We get min image count is 3, max image count is 0, which we saw earlier means that there is no max image count other than that imposed by the fact that our what's the right word? There's physical limits imposed by the amount of memory the physical machine has, but you know, that is what it is. Our current extent is the size that we set. The min extent is the same size. The max extent is that same size. Interesting. Max image array layers is 1, which makes sense because it's not some sort of like stereoscopic output. Supported transforms. Ah, interesting. Is identity. Current transform is identity. Okay, interesting. I wonder what the need for that is. So I guess when it says transform, I assume what it's going to be doing is like rotating the image, or I don't know, maybe collapsing it to monochrome. Maybe that's the sort of thing it does. Yeah, you can imagine like a monochrome output, right? And then what would it do with a RGB images coming in? Supported usage flags as image usage flags, transfer source, transfer dest, sampled storage, color attachment, input attachment. So it kind of sounds like everything. Then the Vulkan loader errored. Because I'm not passing in valid stuff. Okay, cool. In fact, is that the validation layer helping us out there? Cool. Okay, so we're grabbing values there that make sense. We run this, it crashed. And just out of curiosity, if we go back, to main, and we come in here and we delete that. So that is now empty. We run this. Okay, no, it still blows up because what we're calling actually isn't valid. Okay, the validation layers haven't saved us anything yet. I was hoping maybe they had, but never mind. So where are we up to? That aborts, and it aborts because our call to create Swapchain KHR has an invalid set of details in its create info, I guess. Sorry, I already blanked on what I was doing there. Maybe I'm too tired for doing this. Let's just take a second. Let's have a sip of tea. So here we go. I really hope that doesn't make a horrible noise. I've just realised that drinking by the mic is probably making horrible slurping sounds, but I am sorry. I've got a bit of a sore throat, so if I don't do it, I'll be coughing and spluttering. Okay, so where are we up to? We have got our surface capabilities. We know from this that we're going to need a bunch of these details in creating our swap chain. It might be... Christ, what do we do with that information then? So we've got all of these fields. I might just copy paste this block so I've got it later. I have a hand. How do I actually select things? Christ, I feel like a granddad. Text selection, there we go. So that's what that type looks like. Let's stick that in there and comment it out. So those are all of the details that we've got available to us. If we jump back to our Swapchain create call that I sensibly put a bookmark on so I could find it. Let's go back to dragging because I quite like it. We need to work out what all of these things are. So we've passed in our surface, we've got min image count. That is, I think, one of the fields that's just on this. Yes, so we've got min image count. Image format, color space. There's nothing about the max image count. Interesting. So do we just pass through the min image count or do we pass through that max image count? So when it creates the swap chain, that's the number of images, is the minimum number of presentable images the application needs. Okay, let's keep life simple. Let's pass through that min image count. So we've got create info, we've got a surface. Min image count is equal to, I'm forgetting what I've called that thing. Surface capabilities, not properties. Surface capabilities, min image count. There we go. So that's one value. Image format is a VK format value specifying the format of the Swapchain images that will be created. Does this have anything about an image format in it? So we have image count, extent, array layers, supported transforms, current transforms, bugger. Okay. Let's stick that in as a comment so we remember to come back to it. It might be that we need to do some more queries to actually get what we can use there. And the image color space, similarly, I didn't see that in the list. So image color space is another one that we're going to have to think about. Image extent is in there. So the image extent is the size in pixels of the Swapchain images. The current behavior is platform dependent if the image extent does not match the surface's current extent as returned by that thing. On some platforms, it is normal that max extent may be 0, For example, when the window is minimized. In such cases, it is not possible to create a swap chain due to the valid usage requirements unless scaling is selected. Okay, that's a fun wrinkle. We're going to not worry about handling minimized windows yet, but that sounds like something we're going to have to work out later. What can we do with that then? So I think we can just set image extent. Are we going to need that again later? Oh, that's a good question. I actually don't know. Let's assume not. And we'll just set it to current extent. So image extent is current extent. I'm just getting flashbacks. I remember following through the tutorial that this was this and the format and things I think were all stored as class fields, which makes me think probably something else depends on them, but I can't remember what. So I'm just gonna plow on until we actually need it, and then we'll add it in. So we've got our image extent is the current extent, so the images that we create for the swap chain will match the size of our window. Whoopsie daisy. Image array layers is the number of views for non-stereoscopic things, so we require that to be 1 because otherwise all of our logic goes kind of out the window, right? We're not making a 3D app, we're not doing anything fancy like that. Image usage is a bit mask describing the intended usage of the acquired swap chain images, which I think we are going to need to set. But I'm not totally sure what we set the values to. So let's see, what do these have? Image, usage, flag, bits. is not specified. Image usage. Okay, fair. Okay, this is... I guess maybe this is a rub of using the Odin wrapper, is obviously the names of things are slightly different. I do think it's a big win for Odin that they have this nice sort of set wrapper around bit sets. So you're not like shifting bits back and forth and multiplying by different numbers. You're just doing set operations, right? You talk about it in the same terms that you would if you were doing maths, which I think is nice, but... Sorry, getting distracted. What are our image usage flags? So, do I remember all of these? So transfer source, transfer dest is about being able to just shunt images into them from memory. Sampled is if it was a texture, right? So if we were going to draw a quad and apply a texture to it, the texture image needs to have a sampled usage flag. Storage, color attachment. Is there one of these that is like presentation or anything like that? KHR, fragment shading, video encode, invocation. Have I just missed it? Video encode, attachment. Input attachment, transient attachment, depth stencil attachment, color attachment. So I think attachments all mean sort of their inputs to shaders, maybe? Can't remember, to be honest. Okay. Is there a link? Can we jump to this? Is there an explainer in here? I will be honest, I was kind of expecting to see something that was very obviously about presenting images. So I'm not sure what to do with the information since that's not there. So we have transfer, source and dest that they can be used for transfer commands. Sampled, suitable for a descriptor set, for a sampled image or combined image sampler. Storage can be used to create a VK image view suitable for occupying a descriptor set. So that's not us. Color attachment. Create a VK image view suitable for use as a color or resolve attachment in a VK frame buffer. That might be us. Depth stencil, if we're using it for a depth stencil, resolve in a frame buffer. Image usage input. What's transient? VK image usage transient attachment bit specifies that implementations may support using memory allocations with lazily allocated to back an image with this. This bit can be set for any image that can be used to create a VK image view suitable for uses of color, resolve, or input attachment. VK image input attachment can be used to create a VK image for occupying a descriptor set slot. I mean, none of these sound right, do they? Fragment shading rate attachment specifies the image can be used to create something for a fragment shading rate attachment. Video decode is not what we're doing. Video encode is not what we're doing. Feedback loop bit, tile memory bit, QCOM, host transfer bit. Specifies the image can be used with host copy commands and host layout, quantization, emphasis, usage host transfer bit, extension, usage tensor aliasing bit, ARM. I mean, none of those seemed useful, did they? What do we do with that then? Describing the intended usage of the acquired Swapchain images. Can we just set it to nothing? Alright, let's have a Google. Vulkan Swapchain image. Can we jump back? Image usage. Compute shader. Writing to Swapchain image. Actually might be what we care about. My god, that's too big. So far I have a binding the Swapchain to storage image. Added this thing. Use VK image layout general. So I think image layout isn't the same as image usage, right? Do not recommend writing to a Swapchain image for a compute shader. Since Swapchain formats are often not compatible with this usage, I prefer writing to an intermediate image on which I control the format and then blitz the intermediate image to the Swapchain image. I'm curious which format it's in. Vulkan tutorial. Could have a look. Tell you what usage flags are on an image, whether Swapchain or not. There we go. This looks like somebody doing the same thing. Choosing the right number of Swapchain images. Validation error. Initializing Swapchain images. That's just what we're already reading, I think. Improving the render loop in VK guide. Okay, I think we might buckle and look at the tutorial. So what do? We're down here somewhere. They grab a bunch of stuff. They create the Swapchain. What flag do we use? They've got image count. Works out what image count it wants to use. Theirs looks like it's more in depth than ours. S-type, surface, min image count, image format, color space, image extent, image layers, image usage, color attachment bit. Interesting. Do they say why? Image array layers, image usage bit field specifies what kind of operations we will use the images in the Swapchain for. In this tutorial, we're going to render directly to them, which means that they're used as a color attachment. It's just that. You just need to know what a color attachment means. Okay. I guess it does make sense. It's not that they get used as an input for shaders, but they are used as an output. I think attachments just mean things that are available from shaders. Okay, we probably could have worked that out. I keep saying we. I'm here on my own. I'm just talking to myself in my basement. I probably could have worked that out if I thought harder. So that's what we want. What other flags do we need? So we've got image usage. Image sharing mode is a sharing mode for the images. Image sharing mode. Exclusive or concurrent? I'm going to say exclusive because yeah, there's this whole business. So I vaguely remembered this, so I'm going to claim points for knowing this. The fact that we're using a single queue for everything just simplifies this. That I think was the thing I remembered. We have found a single queue that can do both of these things, which means that when we're doing our graphics and presenting, we know that there will be a single queue accessing the image at a time, which means that we don't have to worry about concurrent access. We can just set it to exclusive and life is easy. So we'll take that as a freebie from this. Which again, actually, this would have explained for us here. So this queue family indices is a pointer to an array of queue family indices having access to the images of Swapchain when the mode is concurrent. We don't need to include it because, well, we're not using concurrent, so we're fine. Pre-transform is interesting. I don't know what that does. Is a surface transform flag bits. Value describing the transform relative to the presentation engine's natural orientation applied to the image content prior to presentation. If it does not match the current transform value returned by this thing, the presentation engine will transform the image content as part of the presentation operation. So I guess You must have a current transform. I think we just set them to be equal, right? If it does not match, then it will transform the image. Cool, I guess let's set that to match. Current, whoopsie daisy, current transform is equal to surface capabilities dot current transform. Which I think when we output it was an identity. I guess what this is saying is if I've got a special case where, you know, I want to flip my image upside down on the monitor, I can do that from here. I can set it. Ooh, there is no current transform instruct literal. What have we done wrong? Pre-transform. I don't know if there's any case where the surface capabilities will give me something that's not the identity. Is that like I know it? Yeah, current transform is the identity. So the surface is just giving us an image and it's not doing anything to it, and then our pre-transform wants to do the same. Composite alpha is a flags value indicating the alpha compositing mode to use when this surface is composited together with other surfaces on certain window systems. Was there... Is an option to just be opaque? Yeah, nice. Okay, that makes life simple. So I guess that's relevant if we... You know, I think a lot of people when they're writing terminals, they like to have the option to make their terminal... I quite like to put the types on these actually. Let's do composite alpha flags. Yeah, if you're looking at like your terminal, people like to be able to see like their desktop through it. We don't want any part of that, so why can't I remember the type of this? Composite. I need to say KHR, don't I? There we go. If we jump in there, it's opaque, pre-multiply, post-multiplied, inherit. Okay. Whereas our game, we just want to be opaque all the time. We don't care. Present mode is a presentation mode the Swapchain will use as presents. A Swapchain's present mode determines how incoming present requests will be processed and queued internally. I think we need to do a bit of logic here to see if we can use one of the ones that gives us no clipping. So let's... Or surface tearing, screen tearing. I don't remember that well enough to explain, so I'm going to leave it. Clipped specifies whether the Vulkan implementation is allowed to discard rendering operations that affect regions of the surface that are not visible, which I think we are. So clipped is true. Nice. And then old Swapchain is nil. Can't be nil. Has to be VK null handle. Doesn't exist. Confused. They call VK null handle? No. I am not sure what to do with this information. What type does it say it is? Is a Swapchain KHR, and Swapchain KHR is a distinct non-dispatchable handle. They're not a null handle. Interesting. Can we set it to this? Is that not the same as this? Ah, okay, it's a number. It's a number. Interesting. We could probably... Again, we could leave this off because things... In fact, let's leave it off. Things involved in Odin get initialized to 0. So let's leave it off because it doesn't do anything for us. Okay, so we've got 3 things left to go and work out what they do. We need to set an image format, we need to set an image color space, we need to set a present mode. our image format is the format value specifying the format of Swapchain images created. This will have a thing up here for supported formats. Where am I looking? Min image count, max image count, current extent, min image extent, max extent, layers, supported transforms, current transform. Damn it, I thought it'd be in there. Okay. So if it's not in there, where will it be? I guess it is a surface query. So it's not in this one. Nothing in there about format. What's all of this? Present mode. Supported usage flags representing the ways the application can use presentable images created with the present mode set to FIFO latest ready, immediate mailbox for the surface on the specified device, VK usage. Okay, that's what we were looking for earlier. We have to include that in the set. Implementations may support additional usages. Is that saying that's how we work out our present mode? Supported usage flags is a bit mask of these usage flags representing the ways the application can use the presentable images of a swap chain created with this. Okay, so what do we do with that information? We've got the surface capabilities. We would like to say present mode. Can I remember what these actually are? Is it mailbox? I think is the one that we want. VK present mode. I think it's maybe mailbox, the one we want, and FIFO is always supported. I've got it in my head. What is this saying? Presentable image usage queries. Okay, it's telling us some of these things are an extension. Yeah, okay, so we check it against this. Let's just check. I think mailbox gives us essentially vsync. So it specifies that the presentation engine waits for the next vertical blanking period to update the current image. Tearing cannot be observed. An internal single entry queue is used to hold pending presentation requests. If the queue is full when a new presentation request is received, the new request replaces the existing entry and any images associated with the prior entry become available for reuse by the application. One request is removed from the queue and processed during each vertical blanking period in which the queue is non-empty. As opposed to FIFO specifies the presentation engine waits for the next vertical blanking period to update the current image. So tearing cannot be observed. An internal queue is used to hold pending presentation requests. New requests are appended to the end of the queue and one request is removed from the beginning of the queue and processed during each vertical blanking period in which the queue is non-empty. This is the only value of present mode that is required to be supported. That's what I remember. So this one is always supported. What's the reason to use the other one? So what is this saying? It has a queue of images. New requests are appended to the end of the queue. One request is removed from the beginning of the queue and processed during each vertical blanking period in which the queue is non-empty. What does it do if the queue's full? So they both wait for the next vertical blanking period to update the image. They cannot, both of them can't observe tearing. An internal single entry queue as opposed to an internal queue. What does a single entry queue mean? Internal queue is used to hold pending presentation requests. New requests are appended to the end of the queue. One request is removed from the beginning of the queue and processed during each of these things. Whereas in this case, a single entry queue. So it's a queue that only holds one entry, I guess. If the queue is full, when a new presentation request is received, the new request replaces the existing one. So okay, we don't keep we don't keep this like back buffer of images waiting to go on. We replace them so we'd get a skip if we're running slow, I guess. Any images associated with the prior entry become available for reuse by the application, whereas I guess in this case we get sort of a laggy response. It would go slow and then we would gradually catch up. So I think that is a better behaviour in most cases, but this one is guaranteed to be supported. So I think we will... I mean, what we're making so simple, I hope that we never fall behind. And so this ends up being a bit of a difference without a distinction. Let's try setting it to mailbox and fall back to FIFO if we can't. So mailbox supported will be, it's a good check that we remember how these sets work. Dot, I'm betting it's called mailbox. I can't remember. What's your actual type? You're a present mode. VK present mode. KHR dot mailbox in the set of things that we got out of surface things. So surface capabilities dot supported usage flags, which is an image usage flag. You two are not the same. Image usage flag. Can't type. Image usage flag A. Okay, I'm checking the wrong thing, clearly. You're not in supported usage flags. You are in supported usage flags. A. Is there more to this I can't see? So we get that dot. So it's surface capabilities, supported usage flags. Angry. Because the two are not the same type. The supported VK image usage flags may differ depending on the presentation mode. Can be determined as per the table below. I have no idea what that's trying to tell me. How do I know which of these is supported? VK get physical device surface present mode. Indicating the support. Indicating the support of presentation modes. Okay, that's just a separate call. So what is this talking about? Presentable image usage queries. Yeah, I have no idea what this bit down here is talking about. It sounds like we want to call this thing up here. So we would like to call VK get physical device surface present modes KHR, which is up here, to query the support presentation modes. I mean, Christ, it looks easy when it does that, doesn't it? Okay, so we have supported present modes is equal to VK get physical device surface present modes KHR. We'll pass in the physical device. We'll pass in the VK surface. We will pass in a count, which we will need to make space for. and we will pass in... okay. We can't do it that way. Supported present modes. So the first call, this is nil. We come up here, count is a U32. Get supported present modes res is this. If get supported whatever is not a success, panic, failed to get count of supported present modes. We continue, we go supported present modes equal to, we want to allocate out memory, it's going to be of type present mode KHR. We're going to want count of them. This is not going to want to survive past the end of this block, so we'll defer. I think it was delete supported present modes to tidy it up, and then supported present modes is of type present mode KHR, which means down here we can do that mailbox is in supported present modes. Angry. Expected either a map or a bit set for in. What does it want? Does it want this? Hell, what are we doing with this? I'm surprised that this one here didn't work. So present modes KHR is not declared because that's the one that's declared, and then it complains that the whole thing expected a map or a bit set. Okay, I got you. Right, I don't know if that's blindingly obvious, I'm just getting tired. So, we can't just call in because supported present modes isn't a bit set. It's a list of the supported present modes. Okay, so instead what we would like to do is we would like to say mailbox supported is false, and then for supported mode in supported present modes, if supported mode is dot mailbox, then mailbox supported is true, and we can break. And then down here, we would like to say, it's not format, which one of these is it? Present mode is equal to what? It's equal to dot mailbox. Can I say like this? VK present mode KHR is equal to mailbox. If mailbox supported, else it's this one because it's always supported. Then we can come down here and this can be present mode. My god, that was more effort than I thought it would be. This will still blow up because we're not giving it... What's the VKKHR Swapchain extension enabled? Okay. We're not actually getting the error that I thought we were getting. We're not enabling... We should totally be enabling that. What's this saying? VK create thing, driver's function pointer was null. Pointer was null. I'm going to assume that's because these aren't valid. Rather than the extension's not set up. Because that should be set up by that GLFW required extensions thing. So if we set these to values that we think are sensible and it's still not working, I think then we take a bit of a pause and try to work out what we're doing. Right, so where are we up to? We need to now work out what we're doing with this image format. Right. Is there something up in here about image format? Is that what all this here is? This looks like it's about color space. Surface format has a color space on it. Interesting. Surface format 2 is going to be an extended version. Surface format, defined as all of this. Format is this, color space is that. Beautiful. Query supported Swapchain format tuples for a surface, you call this. Why do we need that number 2? Okay, there's an old one too. Okay. So, VKKHR surface we should have to query the supported Swapchain format color space pairs for a surface, you call this. Okay, shall we do this after present mode? So we've got the right present mode in there. Ooh, what do we do with this? So you take a physical device, you take a surface. We first do an enumerate call. So actually probably a good idea to rename this count to present mode. Supported present mode count. And then down here we'll have a supported format count. Supported format count is a U32. We'll do VK get physical device surface formats KHR renderer physical device global context VK surface. We will pass in this what we're passing in supported format counts. We're passing in a pointer to it, so it'll update. We give this one nil. I did do this one up here, right, didn't I? Because I'm expecting I should have done a raw data somewhere. I don't think I did. Supported present modes. Defer delete. Yeah, I did do it wrong, didn't I? Because I should be calling that twice. Ooh, okay. So let's jump back. So get supported present modes res2. We call the same thing again. Do you know what? I was literally just thinking as I was typing that other thing out. I was like, you know what? We're getting slick with this, right? We're starting to work out. We're starting to get used to how the API works. And then you look up, and I've just screwed it royally. We've got the surface. We've now got this count that we are happy with, and we would like to pass in a raw data for supported present modes to actually populate it. Cool. Okay, ignore that embarrassment. Back to this. So we enumerate, we get our count. We presumably need to check the result on that. As we do up here. My God, Matt. This might be a sign I'm getting too tired. If get supported present modes res2 not equal to success, panic failed to get supported present modes. We come down here, we do this one. This one here is get supported formats res is equal to this, and if get supported present modes res is not what we wanted, get supported formats res is not equal to success. This is one of those, again, we always check it's not success rather than checking for a specific error case, just because it's simpler. If we later find that there are specific error cases that actually can reasonably come up, we can come back and make this more complex. But for now, we keep to our simple, we panic. If it didn't work, we die, we give up. Panic, failed to get count of supported surface formats. So we do that in there. Then we would like to say supported formats is equal to make a slice of VK. Are they called surface format or just format? Surface format KHR with supported format count. We will defer freeing that memory because we're not going to be using it again. So we defer delete supported formats. Defer delete supported formats. What do we do though? Then we're going to call that again. So now we're going to do get supported formats res 2 is get physical device surface formats KHR with all that same guff. So render a physical device, global context, surface, our format count, and now it'll be a raw data pointing to supported formats. If get supported formats res 2 not a success. Realizing now you probably want to wrap this if boolean or if result value not equal to success blow up thing into a helper, but I don't know. It's pretty short anyway. If get supported formats res 2 not equal to success, failed to get supported surface formats. So at this point we have our supported formats and it's a list. It's a list of formats. Those formats are structs with this in it. If surface formats is null, then the number of format pairs supported for the given surface is returned in P surface format count. Otherwise, excuse me. Okay, sorry. If you pass it in, it gives you the count. Christ, I don't know why that threw me so badly. Number of format pairs must be greater than or equal to 1, which makes sense. There must be a way for us to show data, and it must not contain an entry whose format is undefined, which again makes sense. If it includes an entry whose value for color space is sRGB nonlinear KHR and whose value for format is unorm or sRGB format, the color renderable format for tiling optimal must also contain an entry with the same value for color space and format equal to the corresponding sRGB. My God, I don't know what that means. Okay, we're going to ignore that for now. What that gives us is a list of surface formats and color spaces. Okay. I don't know what to do with that information. Do we just pick one? Just take the first one? Should we print them out and see if the information means anything for me? So for supported format in supported formats format print line supported format. Hopefully that's pretty clear. It crashes. So B8, G8, R8, A8, sRGB. And it's got sRGB nonlinear color space. We might want to look up what these things mean. I wonder what unorm means. So B8, G8, R8, A8 is saying that we've got a byte per color channel, and it's 4 channels, so it includes the alpha channel. Do we want to just take the first one of each? There is something slightly scary about just picking the first one, because I guess... So, I don't really know very much about colour space, but if I understand it right, what it's saying is that the values... Okay, so if we've got a byte per colour channel, that gives us values from 0 through 255 for each colour. How those colours map to the actual colour of light that we're going to tell a monitor to display is, for some reason, non-trivial. Like doing it in a way that, as the colours slide up and down, matches what your brain is kind of expecting to see, I think is like a surprisingly complicated task, right? I guess our eyes are better adapted to picking up certain wavelengths or something, so we perceive brightness in a very unintuitive way. So I guess that's why this is non-linear. But I guess it means if we just took the first one, we might end up with things that look good on one computer then looking terrible on another one, even though this same thing is supported. So I wonder if what we do is we say, if this combination is supported, we take it, and if it's not supported, we take the first one that is supported. We could honestly just blow up in that case. Although we don't blow up in the other case either, do we? I think that's what we'll do. We'll say we'll take this combination if it's supported. If it's not supported, we'll take the first one. Because that's a bit like what we're doing. So we know that one will exist. So this is like what we're doing for the present modes. We're going to take the one that we want, unless it isn't in the list, which would be a surprise, but, you know, the world is surprising. If the one that we want isn't in the list, we will not blow up, but instead we'll take the one that we know is there. So what do I do? Just another found Boolean, cycle through, then do a ternary. Okay, so we're going to go through each of the supported formats, and we're going to say if... So I guess they come in tuples. That's also interesting, right? So yeah, because both the ones there have the same... they don't have the same. They both have the same color space. So actually the surface we're using only supports this color space. That's interesting. So they'd need to come in pairs. I guess you might have a situation where you have a format and a color space, and then a different format with a different color space, and then it's not like we can just check them individually. They have to come as a pair. I guess, yeah, which totally makes sense that for the API to be designed the way it is, they come in these tuple pairs. So if supported format, I think we can do format equals B8. In fact, do you have a type? Surface format KHR. Let's run up here and just go, look, are these strings or are these... No, they're enums. So let's do it like if supported format is equal to vk dot surface format, which is a khr extension, and then instead of this we have I kind of thought that would find it. I'm gonna hope this is gonna work. Didn't work. Why didn't you work? You are not an extension but a type. Interesting. Okay, let's do up here then. Let's do preferred format. Does preferred have 1R or 2? Let's go desired format. Is equal to a vk surface format khr, where format is equal to, there we go, and the other thing is equal to that one. Interesting. It looks like they're the first choices. So are these like the default? Okay, that was not the first choice. B8GAR8. B8GAR8. Okay, so maybe there's not a default choice. So we're going to choose the one that is supported on my machine first, if it's supported. Did I call it found up here, or did I call it like supported? Where am I looking? My God, I've missed it. Supported format count, get all the things, supported formats. Where's my list? Where's my iterating over it? Yeah, mailbox supported. So we're going to have in here desired format supported. We'll initialize it to false. We'll go through supported formats, and if the supported format we're looking at is equivalent to desired format, then we set desired format is true, desired format supported is true, and we break out of the loop because there's no need for it. And then down here we can say image format. Just realizing, is that one word? It's not. Again, it messes with my head. I think particularly now that we've been going a while, I'm getting tired. The mix of naming conventions. Like I keep saying, I like snake case, particularly just navigating around in Vim. I think you can do it very slickly, very simply. But obviously, the Vulkan API is all camel cased, so I can make my thing camel cased, but then, I can make my thing camel cased, but then if we have other libraries that have different naming conventions, they all end up different. To be fair, so far GLFW and Vulkan have both had the same thing, so maybe I should have just done that, but we're not even in too deep really. We could go through and change it all, but I'm stubborn, so I'm going with this. So the image format we're using is equal to desired format if desired format supported, else it will be equal to supported formats naught, which the spec guarantees us should exist. I might add that as a check in here just for sanity though. So if supported, len supported formats, and it's not an and, is it? It's an or. So if it reports it wasn't successful, or we get that the length of supported format is 0, which means we can now safely index it down here. And now we can uncomment these two, because this is going to be equal to image format dot format. That's not a great name, is it? Should I call you surface image format? That seems to be the distinction they make. That tuple seems to be called a surface image format, which didn't work down here, so let's do that. And you there are a surface image format dot color space. Yeah, because it's their naming convention. Is that a different word so it gets cased like this? Yes. Phew. So there's no more errors in there. Still, core dumps. Pain. What do we do with that information? Damn it. I thought that would have worked. Okay, so let's jump back to our create Swapchain bit. Where would we be looking? WSI Swapchain. In fact, this, I keep remembering, is where I put my bookmark. So create Swapchain is defined as all of this guff. I'm assuming though the actual call must return us a result, and we're not breaking because that result is a bad value, are we? We're breaking because the Vulkan loader can't find create Swapchain KHR. Was VKKHR enabled? So we have our enabled layers. If we go to where we do create instance, our instance create info does pass through GLFW required instance extensions. I expect that to include for ext in GLFW required instance extensions. Yeah, so if it was 0, that means that we've not got a valid thing. We're getting something, which means that it should be turning it on. And yet when it's getting later, it seems to think it's not. So let's print out our list of extensions. VK, KHR, it's not enabling Swapchain. Do we need to just do that? Is this going to be something that explains up here that we're not paying attention to? Let's go look in here. So we have the surface, querying for support, surface queries. I don't know what present weight is all about. Querying for support. It's going to be under this. So let's go. That was us checking that we've got support. This is all the platform specific stuff. So this we don't care about, do we? Surface capabilities. I mean, none of this has anything to do with the VK, KHR, Swapchain extension. Do I need to literally just go and add it manually? Is that the trick? I'm slightly surprised I didn't run into it here, unless I did and I ignored it. So this we've seen. This is telling us how it's going to work. You have to acquire them and queue the present. Note that the shared presentable image, we don't use that, so we don't mind about it. Querying a swap chain. To create a swap chain, you do all of this. It has a bunch of stuff on it. Old swap chain, create stuff. Device lost. Old swap chain. Maybe this is me not knowing how to read the spec properly. I'm not sure where it actually would tell me about the extension that's needed. I guess the fact these are KHR functions tells me there's an extension needed. I mean, maybe we just try and add it. We go into here. We have our GLFW, what are they called? GLFW required instance extensions. So that's giving us this list. So let's also add our own required extensions list of C string. Are those extensions just strings, or are they typed in some way? Yeah, they're just strings. We're just passing through a list of strings. And so I guess what we want to do is we want to... Oh my god, that's annoying, isn't it? So we want to get the GLFW required instance extensions. Then we're going to have to copy them into a new buffer that will pass through here, and then we'll free. I guess we literally just do that. So down here, we're going to say enable extensions is equal to make a slice of C strings that will have len GLFW required instance extensions plus len. Let's assume this might grow. Required extensions. I've missed the thing to make a new variable. So that gets us enabled extensions. Then for each of these, we're going to want an index as well. Do you know what? Let's do just I. For each of these, we have an extension in I. Let me just check the type. Yep. We would like to do enabled extensions at I is equal to GLFW required extensions at I. Then for extension I in our global required extensions, I'd like to do enabled extensions at len GLFW required extensions, GLFW required extensions plus I is equal to required extensions required extensions at I. Unhappy, why unhappy? Cannot index a constant. Yep, this is a thing. There is a way to make it so you can, but I'm just gonna not bother with it. We come in here. So if we do this, can we now say in here for ext in enabled extensions format print line ext, it runs and it didn't work. It's not that it didn't work because this blew up, it didn't work because we've not got the extra value in here. Because I'm an idiot, I didn't put it in here. Okay, nice one, Matt. VK, KHR, Swapchain. VK, KHR, Swapchain. We run it, there it is. So now we come back down here. We don't need to print this, but we do want to update you to a raw data enabled extensions. Damn it. VK KHR. Okay, just while it's on my mind, we would like to free that when we're done, just because we're making a small effort to be tidy with this. But the driver's function pointer was null, returning VK success. Was the VKKHR Swapchain extension enabled? I mean, I thought it was. This didn't blow up when I gave it the enabled extension name. What do we do with that information then? I guess, do we go back and look at instance create info and see why? There might be some detail we're missing about how that create info actually works. Because it really does feel like we did all of the stuff that we thought we needed. So it's not Swapchain create info, it will be instance create info, which will be a long way back up here somewhere. Instances, where's our create info? Let's see, create has a bunch of stuff on it. We have a create info takes the enabled extent. We got this wrong. That'll be it. Okay. I don't know if that's obvious to everyone immediately. We pass through the pointer to a pointer of enabled extension names. So it's a pointer. The first pointer is to the start of a list, and each item in the list is a string, which, because it's C, it doesn't have a nice way of representing, so it gives it a pointer to the start, and it trusts that they're null terminated. Because we're just passing through a pointer, not like a more complex list type, or like slices in Odin, where they have a length associated with them, we need to also pass through a count. We updated one, we didn't update the other. So if we set that to our new value, interesting, we're getting a different error. Okay, I guess a different error is a kind of progress. What does that mean? Does that mean that the extension isn't supported? This will tell us somewhere what the error values it can give us are, such as error extension not present. So why don't we add in here a format? Let's print the error. What actually is the error? Oh, we've not saved the value. I think we can do something in here where you can make a local value there. I think that's the syntax, and then I'll have the error in my namespace down here. Yeah, error extension not present. Have I made a typo in my extensions? Maybe I should have left this printing. So for ext in overconfident in enabled extensions, we would like to, can we just dump those because we need to see what they look like. Ooh, that didn't look like expected. Am I being silly? Enable extensions. Are you not a string? My hovering isn't working. So VK, KHR surface, VK, KHR... Oh, I'm just printing the whole thing each time. Okay. At least we can see there's 3 of them. There we go. VK, KHR, Swapchain. Is Swapchain meant to be 2 words? Up here, VK, KHR, Swapchain. Okay. So that looks like it is the right extension name, which might mean this is a loader issue. And if that's the case, I actually don't know how to debug that. So that might be something that we need to go off and explore. Before we assume it's that, is there anything worth double checking? Was the VKKHR? Okay. So I guess one thing... No, okay. I had a half thought that we were on a good sign, that we were no longer hitting this like catastrophic failure error. But it isn't. That it's a good thing, because I was about to say it implies we're actually successfully enabling the extension, but obviously we're not, because we're getting an error that we're not enabling the extension. Is there any detail in here about what to do with a error not available? Probably not. Ah, man, that's a painful one. This might be one I need to go and read about off stream, because I think this is going to be a bit of a deep dive. Okay, before we bail, let's Google and just see if there's a really obvious explanation. This might even just be as simple as I have a poorly configured Vulkan SDK, actually. And I've just not installed the extensions. That's possible. Let's see, what's the error actually look like? If we come back, error extension not present. So I want to enable the VKKHR Swapchain, VKKHR Swapchain extension not present. Do we trust the AI? No, because I don't like it making this distinction when we've seen already that those are deprecated. This is an old answer and no longer relevant. I was kind of hoping to see some docs. Kronos forum. Swapchain extension missing, unable to create a swapchain. July 2024. So this one's reasonably recent. Probably recent enough that the deprecations have already happened. Okay, so in my laptop, only integrated graphics. The VKCube executable runs fine, and just to sanity check, VKCube runs fine. So we've got a functioning sort of WSI setup. The SDK I think is installed properly. But when I create an app myself, it can't find the extension. There is a safety check in which I call enumerate device extension properties, and it's present in the list, so it must be supported. These are the device extensions. Are we ever calling this function? Enumerate device extension properties. Enumerate, what is it called? Device extension. Doesn't look it, does it? Device ext. No. But again, I think this distinction between device extensions and instance extensions doesn't really exist anymore. So that may be a bit of a blind alley. But so he's done a call to check it's supported. It says it is supported, and he's still not getting it. Creating a logical device fails. Loader validate device extensions fails. Create device fails. These are the instance extensions that were enabled. 203 views. Oh no. Where's the replies? After the last reply. Well, that doesn't bode well, does it? So the only other message is it being closed. Okay. That's a pain. So you're not going to help us. Except that potentially we need to go and call that function to see. What does this one do? I have to create a logical device when I add KHR Swapchain extension to this thing. Ah, okay, that's interesting. There's a constant for the name. That's probably safer to use than what I'm doing here, right? So if I delete this, is it just that I've got the name wrong? VK, KHR. Well, I'm failing to find it. Is it just going to be called KHR? Maybe it is. KHR Swapchain display Swapchain extension name. Interesting. You're called display. Ah, is that going to be the problem? Is that we're trying to enable KHR Swapchain. KHR underscore Swapchain. Swapchain mutable. There is a thing for just Swapchain. Spec version and... Okay, so that is what we had, right? Sorry, it's wrapping annoyingly if I make it smaller. That's the string that I was using, but I should also be able to use that name, and that feels like there's just no reason to not, right? KHR Swapchain extension name. Okay, so let's do that instead. Let's come in here. We're going to do that is VK KHR Swapchain extension name, just in case we're actually just doing something really silly. So we'll do a save, we'll bin this off. There are a string, but it should be able to make it into a C string. Still doesn't get it. Create instance failed. What if I make it a display Swapchain extension? Yeah, I would have guessed not, because so I think that the display stuff is what we saw in the spec, that there are options for you to does that even make sense with the Swapchain? The spec says that it's possible to present directly to a device, and that has the sort of display stuff in the name for it, but yeah, I'm not sure that is what we want. I think this is what we were wanting. So what do we do with that? There's a whole bunch of people hitting this. This is clearly a foot gun that you can run into. This guy might be doing it on Android, so yeah, this might not apply to us. When he tries to create an instance with the Swapchain extension, it fails with the same error when using enumerate extension properties to get it. Ah, okay, so when he calls this, it's missing. Seems it's only available on the physical device. All the Android Vulkan samples are getting it. Okay, this is super old. So I think that doesn't apply to us, but we can call this enumerate instance thing and see. If you come in here, oh no, have I closed? Yeah, let's go back to here. Can we search for this function? Hopefully it finds it quickly because we're near it, although maybe this means we're not near it. Oh no, it's gonna struggle now. Enumerate instance version isn't what we want. Create info. Whole bunch of info about that. Flags. Validation features. Hey, there we go. So, instance extensions add new instance level functionality to the API outside of the core specification. To query the available instance extensions, call this thing. What's layer name about? Is either null or a pointer to a null terminated string naming the layer to retrieve the extensions from. When the parameter is null, only extensions provided by the Vulkan implementation or by implicitly enabled layers are returned. P layer name is the name of a layer. The instance extensions provided by that layer are returned. Ah, do we need to enable some some layer. Oh, what would this come under? So we have all of this WSI stuff that does the platform specific God damn it, where's the WSI stuff gone? There we go. Is this going to tell me right at the start that there's a layer that must be enabled? See the appendix for additional details of which WSI extension, including which extensions, must be enabled in order to use each of the functions described in this chapter. So that's about extensions. There was nothing in there about a layer, was there? This chapter discusses the Windows system integration between Vulkan API and the various forms of displaying the results of rendering to a user. Since the Vulkan API can be used without displaying results, WSI is provided through the use of optional Vulkan extensions. This chapter provides an overview of WSI. Okay, let's, I guess, Hail Mary. Let's just do a search for layer and see if it pops something. What is this saying? On certain platforms, Vulkan Loader and ICDs may have conventions that treat the handle as a pointer to a structure containing the platform-specific information about the surface. This will be described in documentation for the Loader ICD interface. Blah, blah, blah. This does not affect the Loader layer interface. Layers may wrap VK surface KHR objects. Okay, so there's a bunch of stuff for how Metal and macOS are going to work that hopefully we don't need to care about. We just keep jumping, keep jumping. It doesn't sound like there's a layer that we need to enable, does it? Get display plain capabilities. Oh, okay. So we search for layers, we're going to get confused because layers also refer to some other thing. Bugger. So that doesn't feel like the most useful thing in the world. Is this interesting to us? Up to requested number of global extension properties. Maybe we just call this and see if that's in our list, because if it isn't, maybe there's a layer name that we need to go and find. So, because we're only enabling the validation layers. I wonder if there is a list of these. Layer. Okay, if there is, I'm not finding it in my auto-completing, so let's worry about that separately. Do these things have anything about layers? Not useful things by the looks of it. Can I look for validation in here and see if I can find... There's a bunch of extensions about validation. Features... Cache... And then we're wrapped, are we? Yeah, that's all of them. If we come out of that, we have... So Vulkan, it has enums. Do you have anything about validation? Validation cache. Or is it struggling just because it's a massive file? What do we do? Do you want to search for this instead? See if it's in the enum file. Whoops. It is not. Validation feature enable. GPU assisted. I don't know what all that is. This all feels a little bit desperate though, doesn't it? Just jumping around at random hoping to find a value. Okay, let's try that enumerate thing. So if we go bouncing back somewhere, a long way back now, we saw something about enumerating instance extension properties, and it says if we do not give it a layer name, then it will just give us everything. So in here, can we do... Oh, it's a numerical, so we have to do 2 lots. So in this, can we do debugging? We're going to go count is equal to vk enumerate instance extension properties on no layer name and count. Count is a U32. Res, let's go and do like res1 is equal to that. You take a count. This will be nil. So that'll get me my number. If res1 is not equal to success, then we will panic because that's useful for us to know. Fail to get count. If it isn't a failure, sorry, if it is a success, then we've got a count. So then we want to go, let's call it properties is equal to allocate a slice of vk extension properties. We want count of them. Then we want to go ahead and call that again. So we're going to go enumerate instance extension properties, nil again, count again, but this time we can give it the raw data for properties. If res2 is a failure, we panic again. Else we can format print line. Oh, we can't just print line because it's going to be a list. So for p in properties format print line p. What does that tell me? Nothing. Literally nothing. Just to sanity check, we're going to have debug start and debug end, and it is giving me nothing. Oh, hang on. We're never even getting here. Because we're failing to create the instance. I see. This doesn't take the instance in, does it? So we can actually do this first. In fact, we want to do this first. So let's move that up. We segfault. Aye. Why are we segfaulting? We have a count. We have res something fail if it fails. Properties, we make the thing defer delete properties. Res2 should be writing data into properties. If it fails, panic. That is interesting then. So presumably, is it this call is segfaulting? Have I done something really silly? What is this? Can we delete that? So main. Yeah, before it does anything else, we're trying to run this debugging code. My God, this rabbit hole just seems to get deeper and deeper, doesn't it? We could run it through GDB and see what's going on with that segfault. I guess just to check. So if I come in here and I comment this all out, then we no longer segfault. So it's this bit. Whoopsie daisy. It's this bit that segfaults. Is it because we don't know what this function is yet? Have we called VK load proc addresses? We've not. That'll be why. We don't have the VK functions yet. Okay. So if we're in here, what if I do it after that? In fact, actually, what if I just say I would like to do this? Can this be done right at the start? No. Well, if it can, it doesn't make a difference. Yeah. Does it make a difference to take all of this? What will we do with it? And put it... Application info. I mean, it's not even doing anything though, right? That's the thing that makes this so spooky. Ah, there we go. Okay, that does work. Oh, that's slightly gross. Extension properties, extension name. I'm assuming those are all ASCII values. So they have some maximum value. They have spec versions on them. What do we want to do with that? Where am I looking? So we're down here. Format print line p dot extension name. I'm hoping it knows those are strings. It doesn't. Can I cast those as C string? That's why. Can I do that? No. Can I take the pointer address of this? How long do these look to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. As we say 64. So can we do a slice of this from 0 to 64? Value is not addressable. Why aren't you addressable? No, can't do that. Can't take the pointer address of... I thought it'd be the same as this. Can't take the pointer address of that. Can I do a raw data on it? If it's not clear, all I'm trying to say is I would like to take raw data. It's giving me a fixed size buffer of U8, and I'm trying to say I would like the start of it. And I'm failing to wrangle the types. I did think a slice would do it. Okay, let's try and do it in steps. So we've got p dot extension name. That's a fixed size buffer. Can I do a slice which is equal to the buffer from 0 to max extension name size, vk dot max extension name size, which is defined. That makes you a slice of bytes. I mean, a slice of bytes is a C string, right? So can I then say stir is equal to cast C string slice? And that one is unhappy. Cannot cast slice as a C string from a slice of U8. And if I raw data this, turn it just into a pointer, then you can. And then I can print that. Does that work? Hey, there we go. Okay. So, what do we have here? We have device group creation, external fence capabilities, memory capabilities, semaphore capabilities. Get physical device properties 2, get surface device capabilities 2, get VKHR surface, which we know we needed and we've got. Surface protected, Wayland surface, XCB. So this is all WSI stuff that GLFW is checking for us already. We've got VKHR. We have Swapchain color space. I'm so confused that it's got all of this but no Swapchain. I really don't know what to make of that. So we've got surface. I did see Swapchain in this list somewhere. Debug report, debug utils, headless surface, surface maintenance. Yeah, we have Swapchain color space, but we don't have a Swapchain. Interesting, that's not a KHR one, right? KHR display, KHR get display properties, acquire DRM display, acquire xlib, direct mode display, display surface counter, portability enumeration, debug end. So yeah, we can't enable Swapchain. Unless it lives on another layer that we need to enable. I think we might take a naughty cheat and look at what the Brackeys project's doing. So I'm going to assume people are seeing this without having seen the first stream, if anybody sees this at all. So I have another project that I did that followed the VK tutorial pretty closely and then stripped out all of the stuff for 3D, and I made a little like 2D platformer type thing. I'm explicitly not following through just like copy pasting that or going through the tutorial again, because I found that I think it just stops you thinking. So I feel like I'm learning more this way. But I am super confused, because if I just detach from this and we go find Bracky, I checked this earlier as well. Can I make a new T Bracky? I think this has a make file in it. This does run, right? So I know that I can get a Swapchain, and I know that it's supported on the device. So I think we're going to justify a quick cheat to see what this is doing, because we have failed. Yep, that'll be the one. Swapchain extension name is required. Don't you just love computers? Okay, so if we ls, I need to go tmux attach t0. It's that we're missing a layer. So can we do, what do I want to do? That? There we go. I am interested then, so where did that live? In vendor constants. Is there nothing in here about validation? Doesn't look it, does it? So what are these? Surface extension name. Whether the Swapchain extension name is there. Oh, that's what we just found. Oh no, hang on. Yeah, no, we've already got that. That's not a layer, that's an extension. We've got that already. So that doesn't actually help us. Yeah, it doesn't enable another layer. So this extension descriptor indexing extension name is... Can't remember what that's about. I don't think that's related to this. I think that's about when we want to have an array of textures to refer to later. My God. So what are we doing then? We've got the init renderer. We set up a window. We initialize the Vulkan instance, which I'm assuming is all very similar. We get the required extensions. Yeah, that just passes through the required extensions. This is why I think I'm so surprised. I thought that those required extensions would include the Swapchain stuff. Maybe it doesn't. If we come in here, can we do a format print? In fact, let's do for x in GLFW required instance extensions. Whoops. Can we go format print line X? And I think if we then run that again, my god, pretend you could type Odin run. Ah, that's why I wasn't doing it that way. Let's do a make run. It also doesn't have that Swapchain thing in it. How interesting. What do you make of that? If I just do a search here for Swapchain, so the first mention of it is actually at the point that we're making the Swapchain and using it. Creating a Swapchain. So this is what we've just been doing. This all looks very similar, but it just calls it. And then there's all this guff that we have to relearn. Oi, oi, oi. Recreate Swapchain, clean up Swapchain. So we've got the KHR Swapchain extension being enabled. Have we got another place where I've just messed up and I'm not actually like passing it through? So I could believe that. So what have we got? We've got required extensions. Has our KHR Swapchain extension name. Where are we using required extensions? In this stuff. So this is where I'm printing it out. So the fact that I'm seeing it down here tells me that I am adding it to my list of things. Ah. That's a point. So the other one doesn't have it in the list, but it does work. And actually the reason that our program is blowing up is just that it's not got the extension. Which implies that maybe this is not the solution to the problem, right? No, because the other one is getting it. Yeah, because the other one is also declaring. So where is it using it? Required extension names. It's doing it on physical device. For available extension properties in extension properties, available extension name is equal to that. If it's the same, found is true. So it does a check for extension support. And then when we're picking a physical device, we just check that it is all supported. But I'm pretty sure... So what does that mean? Maybe we're not picking the right physical device. Is that a possibility? I thought, though, I've got it picking the integrated GPU. So somewhere we have pick... What we say... Sorry, I'm in the wrong project now. Go back to here. Here you go, pick... Go back to here. Pick a physical device. We enumerate physical devices, then we iterate over devices, and we pick one. I don't know what to say about that. It just picks one. It picks the discrete GPU if it exists. It doesn't, because I know my laptop doesn't have one. Or it picks the integrated GPU if it's not found the device yet, and it finds an integrated GPU. So at this point, I should be able to format print line. What do I say? Let me just go debug physical device is renderer dot physical device. So where are we then? This is all of our stuff. Extension is not present at that point, so we're never actually getting here at this point. So let's go back, and I guess let's just comment that out. Can't just comment it out because that name is used. So let's do this. Run it again. Debug physical device just has a handle. which is expected. That's what it should look like. Properties dot device type is equal to thing. Properties dot device type dot thing. Okay, let's go ahead and say in here format print line debug device picking. And what actually do we want to output? Let's get our properties dot device type. So we expect this to see an integrated GPU, and then it grabs the integrated GPU device. But it doesn't support the Swapchain extension. I mean, we could explicitly do a check here and see that it does. Am I just missing something? I thought that we'd read this and devices no longer have support for device extensions. I thought it said that all extensions now lived on the instance. So device groups is different. That's about using multiple devices. Device creation. Device create info. The layers are deprecated. Extensions still exist. Oh, that's interesting then. And then if we scroll down a bit, enable extension names is a pointer of enable extension count null terminated. UTF-8 strings contain the name of extensions to enable for the created device. See extensions for further details. So there are instance extensions and there are device extensions. It is worth a bit of a read. So instance extensions add new instance level functionality to the API outside the core spec. To query the available ones, you do all of this. And then this is how you would query the device extensions that are available. Implementations claiming support for Roadmap 2024 must support these things. Okay, so is this the issue then? I'm looking at the instance, I need to be looking at the device. Do they live on physical devices or do they live on logical devices? They're enumerated on a physical device. But that create device we were looking at creates a logical device, right? The create info is used on create device, which returns out this VK device. So yeah, it's in the creation of our logical device, which is further down than that. Should we delete some of this debug stuff then? 'Cause I don't think that was actually useful to us, other than, I guess, sanity checking that things appear to be working the way we think. Let's come down here. We're creating our logical device. It's in here. And yeah, so you take a... Oh, I forgot what it's called. Enabled extension count. Enabled... Do you know what? I'm gutted that that took so long. Do you know what? Let's see. Oh, sorry, I've just seen... There's a chat. Yeah, I've seen the... There's a bunch of... sort of tutorial examples out there, isn't there? So I think I've talked through a little bit. I followed the original Vulkan tutorial through, and I've gone through it a couple of times, but I found just working through a tutorial or like using a like an example implementation, I found that it's hard to actually think it through. So I'm trying to just, I guess, recall what I can recall and then go through the spec and try to work it back out. Which has been a bit slow and painful, if I'm entirely honest, but I think it is going in. I feel like I'm understanding it better. So I don't know how long I can stick with it. I guess we'll see if, I guess, time wears down the willpower. But little details like this, where it's a device extension, not an instance extension, and the distinction that it's device layers that have been deprecated. I think there's a lot of details like that that have just gone by me while following a tutorial or an example implementation. So I'm going to keep stubbornly plodding through. So, I'm now blanking what I had. So, I've got my required extensions. I'm going to take the len of that, and these all end up needing to be U32s. So, let's put that in there. And then we can pass through our PP-enabled extension names. We can give that the pointer to the start of required extensions. I might rename required extensions if this works to required device extensions. If we run that, it wasn't enabled. So maybe that's not it. Ah, damn it, I thought that would work. Have I still got that emptied, actually? I might still have it emptied. I do still have it emptied. So we come in there. Error extension not present. Damn it. Yeah, so now, yep, this is more stuff I've changed, isn't it? I've now got required extensions being required on my instance creation when it isn't. So, enabled extensions. This can all go. This is all stuff I added because I thought I needed to add more stuff than just the GLFW extensions, but I don't. So all of this can go, which means this will now error. These are just GLFW extensions. GLFW required instance extensions and GLFW required instance extensions. Then, oh, thank God. Okay. And validation error showing that the validation wiring up we had is working. I'm going to call that a victory. I know it's an error and it currently still does nothing, but we are getting somewhere. I'll go tidy up all of this debug printing. I'll commit the changes, and then I guess I'll try and make a little summary for myself so I know where to pick up next time. So if I'm within this project, I want to go find all of the places I do format. Let's just jump through them. Debug start I don't need. In fact, this whole debugging block I don't need. Then, let me go regenerate my list. So format, we import it, that's fine. This one, I think is actually a useful error to keep. So, I mean, we've now seen that once in the wild. That's an example of another error type that we want to keep. So we close all of that. Odin run main, that works. We now have a validation error. And this is what I was saying earlier. The validation errors will catch places where we've missed silly mistakes. So we are already in our dinit function, which I think is in this file. We are destroying the device, and the validation layers are catching the fact that we're destroying the device without having destroyed all of its related resources, which is likely a bug. So we would like to come in here and say destroy, which one of these is it? Swapchain, probably KHR, and then we can check that takes a device, a swapchain, and an allocator. We can take our renderer device, renderer swapchain, give that nil, and then if we run it again, bugger, it's still errors. What's the problem? Called before its associated swapchain was destroyed. Did I miss a write? I did not miss a write. All swapchain KHR objects created for surface must have been destroyed before. Okay. It's not destroying it there that's the problem, because the swapchain doesn't hang off of that. It's because I'm over here, somewhere in here, I've got a defer that is destroying this thing. So it turns out that wasn't a sensible place to put it. If we go back into renderer, we would like to do that there. We would not like to do it there. I've not saved everywhere, so I'm still destroying it in the other place. There we go. Validation layers have saved as a bug. Probably not actually a bug, but a potential bug as things got more complicated. So that's nice. Let me just commit that while I've got it all more or less fresh in my head. So what have we been doing? Christ, what have we been doing? We've created a swap chain. So we still don't have access to the images. We still don't have access to image views to actually be able to use the images. We still don't have access to a frame buffer. So there's a few steps left, but we've created a swap chain. We'll call that a flavor of win for the day. And I'll tell you what, I think I did keep a little list in the readme of to-dos, and I think those to-dos probably could do with updating. So make a sensible window we've already done. Draw a triangle is a ways off. So we've now made a swap chain. So I think the next thing to do is to get swap chain images and create image views, which will give us a Vulkan interface to interact with. And then I'm pretty sure we need a frame buffer, but I can't remember what the difference between a frame buffer and swap chain image views is, if I'm entirely honest. So there's going to be a bit of reading to work out what a frame buffer is. Then we can get into making a graphics pipeline, like command submission. Then we can draw a triangle, then we can draw a textured quad, and then we can make a game. Easy. Okay, I think that might be us done for coding for the day, because that was a head scratcher. Okay, let me stop ignoring chat. What we've said. What is your favorite Odin feature? I think, as boring as it is, it's the multiple return values. I think one of my favorite things about Odin is it doesn't do a lot of really exciting stuff. It just does basically C, but nicer. And actually, I've not been taking advantage of it so far. I think I've said a couple of times that like there's opportunities to tidy things up, but just, you know, there's enough to keep in your head as it is working through the various Vulkan bits. Can I think of a good example of a place that does this sort of thing? There's a whole bunch of Vulkan API calls where really what we want is a count of how many of these things there are and the thing that I was interested in and an error value, right? I mean, if we go searching, there must be some of these. Enumerate physical devices, is this a good example? So we want to call enumerate physical devices. It's going to give us out the number of physical devices it found, and we would also like it to give us, you can see further down here, we call it a list of physical devices, so that we can then do our ranking and work out which one we want to use. Because it's all written in C, I can only return a single return value, and it wants that return value to be an error value. So it's kind of stuck, right? It just has to give you that. And so the workaround for that is you have to use all of these output arguments, which clearly works. You can clearly do it. But I think it just reads much less nicely than if this looks like, you know, what would it look like if I was doing it in Odin? You probably have a count, OK, is equal to, if I had like Odin, VK, enumerate physical devices. And it just does the same thing. It's no safer. It doesn't have the advantages like Rust would argue, where it has better memory safety. It doesn't have the kind of like immense Zig build system to argue in its favor. It just did C, but with more ergonomic syntax. And do you know what? I think for both, I guess, like studying and fun purposes, I think that can be good enough. And I'm kind of being slowly won over by, I think I've seen John Blow on various clips make a point to the effect of like, a programming language that makes programming fun is worth something. And part of what makes programming fun is getting out of the way and letting me do things, even if they're bad ideas. I quite like that it means you can just prototype and try random things very quickly, where if you were doing it in Rust, it wouldn't let you compile because it would just break. There's other little things. I quite like the directory-based packaging. So the fact that if I've got a file that's starting to get a bit big and a bit annoying to move around, I can quickly pull that out into another file without pulling those names out into another namespace, so all my other code doesn't break. That's a smaller point though, but I think it points towards this kind of like trend of doing things to try to make the stuff you do regularly easy, if that makes sense. I will say I haven't been using it for a super long time, so there is room for me to fall out of love with it. I think if you rewind a few months, I was all about Zig, and I would have been writing this in Zig, and I would have been telling you a lot of the same stuff about Zig. So, and I think the difference between a language like Zig and a language like Odin are quite small. I think it might even be just as simple as like personal preference on syntax, but it's been a good time so far. I've been enjoying it, so that's good enough for me. Just looking at the time, I've realised it's gotten a little bit late, so I think this might be where we call it for the day. I mean, is that good progress? It's progress of a sort. We've made the swap chain. There's a whole bunch of stuff now to do to make that swap chain accessible and useful. Then we're going to have to deal with the headaches around when the window resizes. We need to recreate the swap chain, but I'm hoping that's pretty straightforward. Once we got it so we can build it the one time, making it so it rebuilds is just as simple as pulling out a function and calling the same stuff all over again. And then we get into the graphics pipeline. So there's a lot of fun. There's a lot of fun content for us to come back to in the future. But that's me done for the day. So thanks for joining. I hope you enjoyed. And I'll catch you later.